Hello everyone. This is one of the DC machine question. Before going to solution, please subscribe to my channel for daily questions in electrical concepts. Now we go to the question. Here it's given a 24 kilovolt 250 volt 1600 rpm separately excited DC generator has an armature resistance of 0.1 ohm. And machine is running at rated speed and field current is adjusted to give an open circuit voltage of 260 volts. This is case 1. And generator is loaded to deliver its rated current at speed of 1500 rpm. Find terminal voltage under these conditions. And one of the point they given is the flux remain unaltered, means flux is constant. Now we know in the nameplate readings it will be the output power. It will be output power. It will be terminal voltage in terms of DC generator and motor. Now we are calculating rated current. Rated current is calculated by using this formula. Now the rated current is in 96 amps. We are going for in case 1. Here the machine is in open circuit voltage, means there is no current flowing in this one. Then the generated EMF will be the terminal voltage. Here the generated voltage is 260 volts. Then at 1600 rpm, in this particular question they given it's running at a 1600 rpm. It's at rated speed. Rated speed means 1600 rpm. Means in 1600 rpm is generating an voltage of 260 volts. Now we got an terminal voltage of 260 volts. In the second case, the machine is running at the rate of 1500 rpm and it's delivering rated current. Here we see the machine is running at 1500 rpm and delivering rated current of 96 amps. Here we already know the flux is constant, but here the mainly mistake is done on the speed. Previously, the speed is around 1600 rpm. Now this running at a 1500 rpm. We already know the formula of EMF generally is K into phi into omega. Omega is in radian per second. If we convert into RPM, it will become 2 pi Rn by 60. Remaining 2 pi N by 60, 2 pi by 60 is a constant one. If you divide E1 by E2, means the case 1 back generated EMF and case 2 generated EMF is equal to N1 by N2, the speed in case 1 and speed in case 2. By substituting value of 260 volts and case 1 speed is 1500 rpm, case 2 speed is 50, case 1 is 1600 rpm, case 2 is 1500 rpm. By this, in the case 2, means when the machine is generating rated current of 96 amps, it is generating a back EMF of, not back EMF, EMF of 243.75 volts. Now we need to find terminal voltage. We already know terminal voltage is EA minus IARA. Means by using the basic KVL loop, we get a formula of EA minus IARA. By substituting EA of 243.75, IA of 96, and armature resistance of 0.1. Now we get a terminal voltage of 243.75. This is case 2. Means in case 1, in open circuit condition at 1600 rpm, it generating 260 volts terminal voltage. It giving terminal voltage 260 volts. Case 2 is running at 1500 rpm, generating rated current 96 amps. Then it's giving a terminal voltage of 243.15 volts.